Chapter 3, we are going to start solving equations. The first lesson is about solving equations using addition and subtraction. Some of the important vocabulary that we will be using, both in explaining how to do the process and in verifying process throughout the rest of the textbook, are going to be equivalent equations, and also sometimes we talk about having balanced equations. I'm going to just go ahead. You can read through this. I'm going to go ahead to the next screen. So when we're talking about balancing, we mean, and they show you a visual here of balanced equations, meaning whatever you do to one side of the balance, you need to do to the other. So in this particular situation, we had x plus 3 equals 5. So we're going to take 3 off of the left side of the balance. And if we do that, we need to take 3 off the right side of the balance in order to make sure that we keep it a balanced equation. We want to do that because we want to get the variable by itself. And when we do that, then we've taken the 3 extra away, so we have x left, and we've taken 3 away from the other side of the equal sign, and that gives us 2. So any transformation you apply to an equation must keep the equation in balance. So you'll see there's a couple different ones here, and showing you the properties there. I'm going to go ahead and just do some in action here. So as shown in the textbook, they tell you to write it as, since I'm starting out with x minus 5, I want x minus 5, and then they tell you to write a plus 5. And that equals, oops, sorry about that. Let's do an undo quickly. A negative 13. And since I added 5 there, I'm going to add 5 on this side. Now, the problem I have with this is as we get into more complex sentences, we lose some of our terms. We get overwhelmed with some of our terms. What this one is saying is now my negative 5 and my positive 5 are going to cancel each other out, leaving me just with x on this side of the equation. And then my negative 13 plus 5 gives me a negative 8. Now, I'm going to quickly give myself some room here. Get rid of that. And I'm going to show you the way that I will be using throughout the recordings and on the board to help you out. And this is commonly called the algebra or the vertical method. So I have my x, I'm starting with the same exact equation, x minus 5 equals a negative 13. I'm going to, however, do the, whoops, back to my pen, do the balanced equation right underneath. That's why it's called the vertical method. Now this is important. Because I'm doing some calculation, I need to make an equal sign. So it tells me that I've already done the balanced equation. Now my negative 5 and positive 5 cancel out, just like they did in the other method. And my negative 5 combined with a positive, my negative 13 combined with my positive 5 gives me my negative 8. This is the method that you will see most often. All right, now this next one, the next example we need to go ahead and simplify first. I'm going to go ahead and only do the vertical. So we have negative 8 equals n minus the negative 4. I do not want two operational signs. And this is why I was trying to break that habit a little earlier. So a negative negative 4 gives me a positive 4. This is why you don't want to always change everything into plus or add the opposite. You're going to get too many signs and you're going to get confused on the balanced equation stuff. Now I have a simplified equation. I need to get my variable by myself. So instead of adding 4, I'm going to subtract 4 or combine it with a negative 4. And that leaves me with just my variable on this side. And negative 8 minus negative 4. The negative 8 combined with the negative 4 gives me my negative 12. Moving ahead here, we'll go ahead and we'll try this with a real life problem. Several record temperature changes have taken place in Spearfish, South Dakota. On January 22nd of 1943, the temperature in Spearfish fell from 54 degrees like I didn't type my degrees in there, at 9 a.m. to a negative 4 degrees at 9:27. By how many degrees did the temperature fall? So when we're doing this, we need to go ahead and figure out the operation. We're going to figure out what the difference is. So we have it finished at a negative 4. We know that part. We also know that it started at a 54 degrees. We want to know the difference between that, so this is a subtraction. And let's just use T for temperature. All right, now this one's a little bit different the way that I set it up, and I set it up this way to show you what would happen if you had a negative variable. So I'm going to start, I was using my finger, I'm going to try using my pen again. I'm writing too large with my finger. I didn't know. I thought it might be a little bit more accurate. So this time I still want to get my variable by itself. So I'm going to get rid of my 54. So it was a positive 54. I'm going to go ahead and subtract 54 from both sides. That leaves me with just my variable on the right hand side this time. And over here I have a negative 58 degrees. Now, I don't want to know what negative T is equal to. So I want to find out what T is equal to. The way I can get rid of that is to multiply both sides by a negative 1. Again, keeping it balanced. So I have negative T times a negative 1 would give me a positive T, and negative 1 times a negative 58 will give me a positive 58. Now, the last step then is, if I was going to answer this correctly, it was a 58 degree change, but it fell to 58. It fell 58 degrees. So for the answer to the change in temp, it would be a negative 58 degrees. It fell 58 degrees. Okay, so this is the algebra part that I wanted to introduce, the negative variable, and then this is the final answer of change. And the last one that we're going to have, it says match the real life problem with an equation. So you're going to notice we're using the same numbers in here. So you owe $16 to your cousin. You paid X dollars back and you now owe $4. How much did you pay back? Or the temperature was X degrees. Put my degree in there again. Whoops, somehow I got on my eraser. Degrees. It rose 16 degrees and is now 4 degrees. What is the original temperature? And then we also have a telephone pole extends 4 feet below ground and 16 feet above ground, which is the total length of the pole. So if we are looking for letter A, you owe $16. If you owed 16, you could subtract the amount you paid back and you would get what you now owe. So that would be this sentence here. You owed 16, you subtract the amount you paid back, and now you owe $4. Okay? If we're looking for the next one, we would go with the original temperature. It rose. We don't know what the original temperature was, but we know it rose, so that would be positive. So that goes with this one. So hopefully this last one, a telephone pole extends 4 feet below ground and 16 above ground. What is the total? So we would have the total length below the ground, and then we would have that was 16 above ground. And that is the last example for lesson 1.